All right, so we want to look at this problem here. What we'll do is we'll read it, and then we'll use that reading to set some things up. So again, whenever we have a word problem, we read it first, and we look at what we can do here. So, in a certain year, 30% of adults in a certain country viewed a college education as essential for success. For the following 10-year period, this percentage increased approximately 2.8 each year. The percentage of adults from this country who viewed college education as essential for success X years after the first year can be represented by. And what we can do here is we can make an equation out of this, and we can start talking about some certain things. So let's look at 30% was what happened on the first year. So, and then in every year after, it went up by 2.8%. So I'm going to come over here, and I'm going to write down what we know. We know that our starting percentage is 30%. And each year, or per year, is 2.8. And so we can talk about our final percentage, y, is the starting percentage, and I'm not going to put the percent sign in, plus 2.8 per year after that starting year. And so this reads back what we get out of our equation here. And so we can look at our starting point as the b value in that linear equation, and we can look at the each year as the rate times what's measuring each year, the x value. And so we come in here and we enter that in. And we see that this is the value that we needed for this. So if we kind of break down the pieces, we get the ability to write an equation for this. And I think Pearson actually does this without the y value. It'll come in and it won't do the y value on it. I think Pearson wants the 30 plus 2.8x as an expression for it. But our job isn't always to satisfy Pearson, but to figure out what these things are doing in the background.